Welcome to The Explainer. Ever stop to think about what really keeps your data safe? I mean, it's not just about having a strong password. Behind the scenes, there's this hidden architecture. It's called an information security model. Think of it like a blueprint that decides who gets to see what. And today, we're going to pull back the curtain on these super powerful, invisible rules.
So how does an organization like a bank or even the military actually enforce rules like top secret or for internal use only on their computers? I mean, it seems like a simple question, but the answer is pretty complex. See, anyone can slap a top secret label on a file. Easy. But how do you make a computer actually obey that rule? Well, that's exactly where these models come in. They're basically the logic engines that turn a security policy from just wishful thinking into, hard-coded reality.
All right, so here's our game plan. First, we'll look at the blueprint for security. Then, keeping secrets safe. After that, we'll tackle how to make data trustworthy. We'll also get into handling complex conflicts of interest. And finally, we'll put it all together. Let's dive in.
Okay, first up, the blueprint for security. This is the one rule that really governs all the others. Before we can even talk about specific models, we've got to understand this foundational principle because it's the bedrock for everything. So, what is an information security model exactly? Well, it's a formal way to enforce security policies. But it's not just some policy document sitting in a binder. No, it's more like a formal, almost mathematical rulebook that's baked right into the system's DNA. Here's a good way to think about it. It's the difference between a flimsy keep-out sign and a locked, reinforced steel door. And this really gets to the core idea, which comes from something called the state machine model. The guiding principle is this: the system must always be in a secure state. The whole goal is to make sure that no matter what you do, the system never, ever slips into an insecure state. It's kind of like a game of chess, right? As long as every single move you make is legal, the game itself stays valid and fair.
So this really breaks down that core logic. Look, you start in a secure state. The system's safe. Then, a transition happens, some kind of action or event. The key is that the result has to be a new secure state. The system is still safe. If you can guarantee that every single one of these transitions is secure, then the whole system, by definition, stays secure. It's a simple idea, but it's incredibly powerful, and it's the foundation for everything else we're going to talk about.
All right, with that foundation in place, let's move on to our second part, keeping secrets safe. This is all about the Bell-LaPadula model, which handles confidentiality. And to do that, we're going to look at a model that was originally developed for the U.S. military.
So the goal here is to protect confidentiality. It's all about preventing secrets from leaking out to people who don't have the right clearance. The Bell-LaPadula model, it was literally born from this classic military problem. How do you stop secrets from leaking? So its entire focus, its one job, is confidentiality, making sure data doesn't flow to a place it shouldn't be. It's all about enforcing a kind of one-way data flow.
And it does this with two really simple but kind of brilliant rules. First, you've got no read-up. This one's pretty obvious, right? You can't read information at a higher security level. If you have secret clearance, you can't just peek at a top secret file. Makes sense. But this second rule, no write down, this is where the real genius is. It means you can't write information to a lower security level. So, someone with top secret access is literally forbidden from copying that info into an unclassified document. It stops leaks right at the source.
Okay, on to part 3, making data trustworthy. We'll look at the Biba and Clark-Wilson models for integrity. So Bell-LaPadula is great for keeping data secret, but what about keeping it trustworthy? How do you make sure the data hasn't been messed with, either by accident or on purpose? Well, that goal is called integrity, and it needs a totally different way of thinking.
And first up for integrity is the Biba model. The easiest way to think about it, it's basically the exact opposite of Bell-LaPadula. So instead of no read up, Biba has no read down. That means you shouldn't trust information from a less reliable source. A highly trusted report shouldn't be pulling data from some random, untrusted file. And then there's no write up. This is to stop you from polluting more reliable data with less trusted edits. You definitely don't want an intern accidentally rewriting the official company financial records, right? That's what this prevents.
But that raises a question, right?
how does a business ensure data integrity in the real world? It's often more complicated than just simple trust levels. BIBA's great in theory, but for a commercial organization, it's not just about who you trust, but how things get done. The process matters. And that leads us to our next model, one designed specifically for business. And that's the Clark-Wilson model. It's all about integrity through process. It has 3 key parts. First, trusted programs. This means users can't just go in and edit important data directly. They have to use a trusted application, like the company's official accounting software that has its own checks and balances. Second, separation of duties. This is huge. A critical task has to be split between multiple people. So one person might submit an expense report, but a different person, their manager, has to approve it. And third, there's a full audit trail. Every single transaction is logged and tracked. It's basically the digital version of that old saying, trust but verify.
Okay, Section 4, Handling Complex Conflicts. This is the Brewer and Nash model, or the Chinese wall. And this tackles a really modern problem. Think about fields like finance or law. You absolutely have to prevent conflicts of interest. So how do you stop a consultant who's working for, say, Company A from even looking at sensitive files related to Company B, who happens to be a direct competitor?
Well, that's where the Brewer and Nash model comes in, famously known as the Chinese wall. So if you access data for Company A, a wall goes up, and your access to data from its competitor, Company B, is dynamically blocked. And that word, dynamic, is the key. It's not a static rule. The system is actively watching what you do. The second you open a file related to Company A, bam, this virtual wall goes up, and the system automatically blocks you from touching anything from Company A's rivals. The rules literally change based on your actions, in real time. It's pretty clever.
All right, final section. Let's put it all together. We'll create a little cheat sheet for these security models. So we've looked at models for keeping secrets, for ensuring data is trustworthy, and for handling conflicts of interest. Now let's just zoom out for a second and see how all these pieces fit.
So you might be wondering, how do these abstract ideas actually work inside a computer? Well, under the hood, they all pretty much boil down to something that looks like this, an access control matrix. It's really just a simple grid. You've got your users on one side, your files and databases on the other, and the grid just spells out who can do what. Can user A read and write to file 1? Yep. Can they access the DB record? Nope. All those fancy models we just talked about? They're just the intelligent rules that decide what gets put in these boxes. And this really gets us to the most important takeaway. There is no single best model. It's all about picking the right tool for the right job. So here's a quick cheat sheet. If you need to keep secrets safe, you're going to use a model like Bell LaPadula. If you need to make sure your data is accurate and trustworthy, you'll look to BIBA or Clark-Wilson. If you have to avoid those conflicts of interest, you use Brewer and Nash. There are others too, for things like controlling permission sharing or stopping information leaks. The point is, each model is a specialized solution for a very specific problem. And all this leaves us with one really critical question for the future. We now know the classic blueprints for security, right? But how do these ideas have to evolve to protect us in a world that's now full of AI, massive cloud computing platforms, and the Internet of Things? Answering that question, well, that's the big challenge for the next generation of security architects. Thanks for joining us on The Explainer.